Salam sejahtera, nama saya Muhammad Zain Mustaqim bin Hasri. Nombor matrik saya 05 DKA 22F1076 dan saya daripada kelas DKA 5C. Dan untuk memulakan pembentangan projek design RC Design ini, kita dimulakan dengan slab B1C 7 sehingga 10. Untuk maklumat slab ini, LY dia adalah 10,000 mm ataupun 10 meter. Manakala untuk LX pula adalah 6,700 mm ataupun 6.7 meter. Dan QK yang digunakan adalah 2 kN per meter square. Langkah yang pertama adalah permanent action. Jika sama dengan 24 kN per meter cube darab dengan 0.150 tambah 1.5 kN per meter cube, kita akan dapat 5.1 kN per meter cube. Yang kedua, design action. W sama dengan 1.35 darab dengan 5.1 tambah 1.5 yang didarab dengan 2, kita akan dapat 9.885 kN per meter square. Yang ketiga, structural length. 6.7 meter darab dengan 10 meter, kita akan dapat 67 meter. Yang keempat, slab thickness. 6,700 bahagi dengan 26, kita akan dapat 257. Yang kelima, ratio. 10,000 bahagi dengan 6,700, kita akan dapat 1.5. 1.5 kurang daripada 2.0 ialah two-way slab. Untuk spesifikasi material pula adalah yang pertama, concrete strength ialah 30 kN per mm square. Yang kedua, design life. Kategori 4, 50 tahun. Yang ketiga, durability 30 mm dan yang terakhir, fire resistant range 90 15 mm sehingga 20 mm. Untuk slab ini adalah dua adjacent edge discontinuous dan flexural design slab ini 257 sama dengan tolak dengan 30 tolak 10 bagi 2 sama dengan 222 mm. Seterusnya, untuk momen pula, yang pertama, edge short span. Momennya adalah 58.322, K-nya adalah 0.039, AS request 636, AS provide 670, hash 16300, LYLX 0.059. Yang kedua, middle short span. M 77.103, K 0.052, AS request 840, AS provide 896, hash 16225, LXLY 0.076. Yang ketiga, H long span. M 15.087, K 0.010, S request 166, S provide 168, hash 8300, LXLY 15.087. Dan yang terakhir, middle long span. M 19.968, K 0.013, AS request 218, AS provide 228, hash 6125, dan yang terakhir LXLY 19.968. Seterusnya untuk shear short span. Yang pertama adalah 53.379 kN. Yang kedua 34.597 kN per meter. Untuk long span, yang pertama adalah 26.491 kN per meter dan yang kedua adalah 17.219 kN per meter. Untuk design shear force, sebelum mencari max design shear force, kita perlu mencari F. F sama dengan 9.885 didarab dengan 6,700, kita akan dapat 66.73. Untuk max design, VED sama dengan 0.6 darab 66.73, kita akan dapat 39.738. Seterusnya, design shear resistant. K sama dengan 1 tambah 200 bahagi dengan 222, kita akan dapat 1.90, iaitu kurang daripada 2.0, kita akan gunakan 2.0. Yang terakhir, P1 sama dengan 894 bahagi dengan 1000 didarab dengan 222, kita akan dapat 0.004, kurang daripada 0.002.
Seterusnya saya akan membentangkan berkenaan dengan beam design untuk beam 6/B EI Sewall. Oke, untuk material span panjang 6 meter, width 4 meter, thickness 110 mm dan beam size 225 darab 500. Bar 1 bersama dengan 10 mm, bar 2 15 mm dan link 10 mm. Karakteristik QK bersama dengan 2 kN per meter square dan GK 5.1 kN per meter cube. Untuk unit weight 30 kN per meter square dan GK bersama dengan 30 kN per meter cube. Untuk steel FYK bersama dengan 500 Newton per mm square, dan untuk link FYK bersama dengan 500 Newton per mm square. Oke, yang kedua, durability. Concrete cover bersamaan dengan 30 mm, dan yang ketiga, size. BW bersamaan dengan 225 mm, HF bersamaan dengan 110 mm, dan N bersamaan dengan 500 mm. Manakala B1 bersamaan dengan 1387.5 mm dan B2 1387.5 mm. Actual flange width bersamaan dengan 3000 mm. Untuk yang keempat, surf weight. Surf weight bersamaan dengan 3.3 kN per meter square, dan untuk finishes bersamaan dengan 1.5 kN per meter square. Seterusnya, permanent action. Surf weight W wall O bersamaan dengan 2.19 kN per meter. Manakala wall 1 bersamaan dengan 6.38 kN per meter. Wall 3 bersamaan dengan 6.38 kN per meter. Variable action. Wall 1 0.5 times 3 times 3 bersama dengan 4.50 kN per meter. Untuk wall 2 0.5 darab 3 darab 3 sama dengan 4.50 kN per meter. Untuk design action WD bersamaan dengan 9.9 kN per meter. Seterusnya untuk main reinforce WD bersamaan dengan 13.275 kN per meter. Untuk AS 345 mm square. Untuk allowable bersamaan dengan 19.09, manakala untuk actual 7.834. Untuk Fs 262 Newton per mm square, dan ini adalah bar spacing yang telah kami dapat, yaitu 4 mm lebih kecil daripada 150 mm.
Assalamualaikum and hi guys, my name is Muhammad Syar Aiman bin Tunku Muhammad Sulahan. My metric number is 05 DKA22F 1046. For my part, I'm gonna show you how to calculate a beam designs. So you can see here, this is my plan truss house. I will calculate beam B 2 until 9. Okay, for the step 1 is loading and analysis. First of all, we list all our material to calculate. My plan B equal to 2550 L 6700, and the slab thickness is 110, and the beam size is 225 times 550 mm. For the finishing 1.5 QK, we are using 2.0. For FCK, we're using 30, and FIK is 500. Okay, step 1, we calculate the action on slab. Surf weight 0.11 times 30, and we got 3.3. And then we search for characteristic permanent loads GK. My GK is 4.25, and the characteristic variable load QK 2.0. After that, we calculate the length from slab, and the formula you can see in the slides. So for my calculation is 0.5 times 4 times 2.5, and we also calculate the brick wall, and then we calculate all the GK to calculate the design actions. And the second, we calculate the action on beam, Ly over Lx on the plan. So for my plan, we use Ly equal to 6.7 and Ls for 2.55, and I got a 2.6. So my shear coefficient is 0.5. After the calculation, we finally calculate the design actions. The formula is 1.35 GK plus 1.5 times QK. Okay, for the step 2, it is flexural designs. In the flexural designs, what we calculate is a span B2 until 6 and span B6 until 9. I don't need to show you how to calculate the span B6 until 9 because it's the same. Okay, first of all, we are using the shear force in the diagrams, and for my diagram is 1 to 9.06. How I get it? I using a beam designs to get a BMD and SFD and use the shear force in the diagrams. Okay, the calculate for the MF is 0.567 FCK BEFF times HF and times D minus 0.5 HF. By using this formula, just insert the the data that you got. After you calculate the MF, you need to make sure the MF is more bigger than MED. MED is means shear force. And then after you searching it, you need to find K. The formula for the find K is MED over BD square FCK. And then after you got K, you need to calculate the Z. The formula for Z is D times 0.5 plus 0.29 minus K over 1.134. After that, you need to calculate as request. After you got calculate the as request, you can take a data from as request to find the as provide. After you find the as provide, you can calculate as minimum and as maximum. You can see the formula that I put in my slide. So for the step 3, we're gonna find a shear force. We need to find a VRD max and VW. So I got VRD max for my plate is 3x0 kilonewtons, and for the VW I got a 0.35 mm square, and the formula is V over F YW dz ton. Okay, after you find a shear force, the step 4 is deflections. For the deflections, we need to find a P that equal to as request over BD and PO and finally P. Okay, for the P, I got a 0.08, and for the PO, I got a 0.015, and the last one I got 0. So you need to make sure after you calculate all the P is bigger than PO, so you can go to the next step. Okay, after that, step 5, crackings. What we're gonna doing here is we're gonna find the crackings. Before that, we need to know our W max, and then we calculate the Fs. The formula for Fs is Fyk over 1.15 times Gk plus 0.3, and then times Qk over 1.35 times Gk plus 1.5 times Qk, and then we times again with 1 over 8 and times again with as request over as provides. So for my calculation here, you can see I got 232 newtons. Okay, for the last one is detailings. What we're gonna do in this step 5 is we draw a beams and just put the data, insert the beam, and then we can know how much we need and how much we can provide. That's all from me. Thank you.
Hello, my name is Nolan Anak Norasman and my registration number is 05DKA22F1003. So today I will be presented column design. The column that we calculate is column B6. So this is the figure for the column that we use. The width for the column is 300 mm and for the depth is 350 mm. For the materials, the concrete FCK is 30 Newton per millimeter per second. For the reinforcement steel FYK, we use 500 Newton per millimeter square. And for the size, 300 times 350 millimeters. So for the first step, we will calculate the effective length. Effective length for Z uh, is 4.625 times 0.8 equal to 3.7 meter. And for the effective length of Y, 3.6 meter times 0.8 equal to 2.9 meter. The second one, we will calculate the design moment. For the moment, moment implemented Z 1800 times 3.7 over 400, we get 16.7 kilonewton per meter. And for the moment implemented Y, 1800 times 2.9 over 400 is 13.1 kilometer per newton per kilonewton per meter. So for the design moment of Z, um, 77 times 16.7, we get 93.7 kilonewton per meter. And for the moment design of Y, we get 58 plus 13.1, which is 71.1 kilonewton per meter. Next, for the third step, we will calculate the biaxial bending. For the EZ, we get 71.1 times 10 power of 6 over 1800 times 10 the power of 3, we have 40 millimeters. And for the EY, we get 93.7 times 10 the power of 6 over 1800 times 10 the power of 3, we have 52 millimeters. And then we calculate the biaxial bending. For the biaxial bending EZ, we get 1.1, which is bigger than 0.2. Next, for the biaxial bending Y, we get 0.9, which is also bigger than 0.2. For the fourth step, we will calculate the reinforced design. So this is the figure for reinforced design, which for B is 350 millimeters and D 300 millimeters. So for the effective depth, we get for H, we get 301.5 millimeter, and for the B, we get 251.5 millimeters. We then calculate moment of Z and Y. We will be divided it with h and b provided. So for the first one, moment of z will be divided by h. So 93.7 divided by 301.5 equal to 0.31. And next, for the moment of y equal over b, we have 71.1 divided by 251.5, we have 0.28. So for the moment total of z, we get 100 kilonewton per meter. Next, we will calculate the D2. The formula is C norm plus link plus 0.5 bar. So we get 30 times plus 6 times 0.5 times 25. We have 49 millimeters. And then we will calculate D2 divided by H, which is 49 divided by 350, we have 0.14. So next, for the N, we will calculate N divided by BHFCK, and we get total of 0.57. And next, we will calculate the moment. Moment will be divided with BH square FCK. So the value we get is 0.11. So for the next, ASFIK will be divided with BHFCK, so we get 0.48. So according to design chart, we get the rectangular column D square um, divided by H equal to 0.15. So we will calculate the AS. Formula for AS is 0.48 BHFCK divided by FIK. So 0.48 times 300 times 350 times 30 over 500. So we get 3024 millimeter square. So next, we will calculate the AS minimum, which is 0.1 um, uh, times NED divided by FYD. Next, the value we get is 414 millimeter square. So next, we will calculate the link size. Link size is 0.25. Sorry, we will calculate the link size. We will calculate the link minimum first. So 0.25 times 30 equal to 6 millimeter. So we will use 8 millimeters, which is slightly bigger. So for the link distance, SB Max, we use the laser of 300 millimeters, use H8 to 300 at section 300 with below and above beam and at lap joints. As we max, we get 0.6 times 300, which is equal to 180 mm. So for the fifth step is detailing. We use this is the detailing of the column. Before we calculate the actual detailing, we use H8 175, H8 300, and H8 175. For the last calculation, we will check biaxial bending. For the AS, we have 3024 millimeter per second. For the ASZ, we have also 3024 millimeter per second. And for the ASY, we have 1964 millimeter per second. And then we will calculate it N over BHFCK, and we get 0.57. Next, for the D to Z over H, we have 0.14. For the Next step, we will calculate the ASZ FYK over BHFCK and we get 0.48. For the next calculation, M, the moment, divided by BH square SEK and we get 0.11. For the um, next D to Y divided by B, we have 0.16. For next, for the ASY FCK next, divided by BH FCK, we get 0.31, and for the moment, again, divided by BH square FCK, we get 0.08. For the NRD first one, for the NRD, we will calculate the 0.567 um, FCK AS plus 0.87 FYK and the answer we get is 3100 and 101.5 kilonewton. For the next calculation, NAD divided by NRD, we get 0.58. Next, for moment of EGZ, we get 93.7 kilonewton per meter, and for the moment of DY, we get 71.1 kilonewton per meter. After that, we will calculate the MEDZ divided by MERDZ, the, the power of A plus the result of MEDY divided by MRDY, power of A. And the answer must get equal or below 1.0. So the answer we get is 0.696, which is below 1.0, and the result is okay. So this is the final detailing for the column design, which is exactly the same as the fifth step. So that's all the presentation from me. So thank you.